Now, where we finished off on Thursday was we were talking about higher order functions, if you can remember. Higher order functions are functions that take another function as a parameter. We call that other function a callback. And then we were looking at a whole set of examples of higher order functions, and they're all related to the array type, just as a kind of convenience, really. So the only one that was left that we had to look at was this reduce method. And it's more complicated, the most complicated of the ones that we've looked at. So that's why I'm actually deciding just to cover it. Maybe it's been, but I'll go through it at a fair pace. So the reduce method, the idea behind it is it takes an array and it reduces that array to a single value, which we call an accumulator. And it returns the accumulator value. So in general terms, what we're looking at here is we've got some source array, an array of elements, doesn't matter what the elements are, they could be objects or anything else. And we pass a callback as before to the reduce, but we also pass it a second argument, which is the initial value for the accumulator. Now, if the accumulator is simply a primitive, like maybe a number, then maybe the initial value is 0 or whatever. But if the initial value, if the accumulator is something more complex, like an object, then we need to pass it the initial value for that object. And the idea is in the callback that you pass to reduce, the callback kind of incrementally computes the accumulator as it's processing each element in the array one by one. It's updating the accumulator based on the current element that it's processing. And always the callback has to return the updated value of the accumulator. So they're the important things to remember. You've got to pass the initial value of the accumulator to reduce itself. And within the callback, you've got to return the updated value of the accumulator. So an example hopefully always clarifies these things. Hopefully. So let's see.
Okay.
Okay, so this is the case study. This is the source code that we're looking at. Here we've got our index.html. I'm going to start my live server down here. Look, my developer tools. And here's my script. And I started talking about this the last day. So at the beginning of my script, which is the same as the beginning of all of the other scripts, I'm using this random user web API to return a randomly generated array of user profiles, which are really kind of objects with some information about a fictitious person, let's say. So I'm going to scroll on down because I talked about the beginning of this. I'm going to scroll on down to the last example of using the reduce method. Now, my objective here is I want to break up my 10 users into their age categories. And my age categories I've just arbitrarily decided are these. So I want to find out how many of my users are 25 or less, how many of them are between 25 and 50, how many are between 50 and 75, and how many are over 75. Okay, so this is actually my accumulator, the structure that my accumulator is going to take. It's actually going to be an object. And the initial values for each of these properties within this object is 0, obviously. But at the end of invoking the reduce method, then these values will change based on what my reducer has discovered. So that's my objective, okay? And that's my accumulator. So that's why I'm saying that the accumulator, it can be something simple like a primitive, or it could be something more complex, which it is in this case. Now, I've also just got one or two kind of convenience functions which we use inside in the reducer. This function, well, this is not a function, but this is just a statement. What this statement does is it takes the array, or my object, sorry, takes this object up here, and it just grabs the keys from that object and it stores them in an array. So the array that I've highlighted there, the variable that I've highlighted there, that's going to be set to an array of strings where the strings are the keys of this object. That's fine. That's that. Here, I've just got a little convenience function for myself. And what the function does is if you pass it a numeric value, really, but I'm just saying if you pass it an age, then what it will do is it checks to see where that age falls within my 4 categories, and it returns, essentially it returns one of the entries from this array based on that. So if we just take the very first line, right, I'm saying if the age is less than 25, then I set this local variable to the first entry in this array here. So in other words, that would be the string 25 minus. The else checks to see if the age is between 25 and 50. If it is, then it finds the second entry in my array of strings and assigns that to this local variable. And this is the variable that we return ultimately. So the purpose of this little function that I have here is you pass it a numeric value, i.e. a person's age, and what it returns is one of these keys here. Finally, we come to reduce. I'm calling reduce on my profiles. Profiles is going to be my array of profiles that has been returned by the random user web API. Here's the callback. Begins here and ends here. And here's the initial value for my accumulator. The initial value for my accumulator is essentially this guy here. And in the body of my callback, you know, I don't think code is that difficult. In the body of my callback, first of all, I call my convenience function and I pass it the current person's age. And that's going to return essentially the key within my accumulator that's going to be updated. I then update that particular property within my accumulator. I add 1 to it because I found a person within a particular age group. And as I've repeated, you have to return then the updated accumulator at the end of your callback. So, okay, I'm back. Some of you are back. My entire network collapsed there, and trying to get it back was a bit of a challenge. Right. Let's pretend it never happened. Can somebody tell me from your side whether this is recording or not?
Yeah.
Yeah, it says it's recording.
Okay, all right. Good. Let's see. Take two, as they say. Okay, let me start my live server again. Is it still running, maybe? Okay, and look, so my accumulator, here's the accumulator after it has gone through the reduce. So you can see it's computed what there were 4 people between 25 and 50 and 6 between 51 and 75. And if I do a manual refresh, here now, my script is going to run all over again. It's going to get another set of users and their age breakdown looks like this. Okay, so looks like the accumulator or the reduce is actually working. Sorry. So the purpose of this example was to give you a better indication of how flexible the reduce is in terms of this notion of computing an accumulator. An accumulator can be, its value can be as simple as a primitive, or it can be more complex, as it is in this case. It's an actual object. The trick with reduce is, like, when you look at the code, you say, yeah, I can understand that. The trick, though, is, or the skill is, identifying the opportunity to use the reduce, to realize if somebody puts a particular problem to you that you have to solve, realizing that the solution is to use the reduce higher order function. That's kind of where the skill comes in, if you like. Anyway, I'll just pause for a second, just in case there are any questions about the particular example that I'm showing you. Okay. Anyway, in one of this week's labs, which is the JavaScript, if I go over to Moodle, in the functions lab, this one here, you get an opportunity to use not just reduce, but map and filter as well. And there are 2 examples of 2 exercises involving using the reduce. One is a simple enough one where you're just computing a primitive accumulator, like a numeric value. And the second one then is akin to the example that I was showing you there. So we'll see how you get on. Right, that's our review of the JavaScript language complete. The next thing I want to talk about is automated testing. So I want to start talking my way through this set of slides here. So if you like, this topic now is kind of proper agile stuff, if you like. Just escape out of this if I can. Now, automated testing is a topic we'll come back to a number of times actually through this module. So why automated testing is so important in an agile development environment is because the agile development process is an iterative process. By that I mean you go through a number of iterations where each iteration involves designing, implementing, testing a subset of the overall application's functionality. You might remember the first day I spoke to you and I gave you an overview of this module, and I had a kind of diagram up on the in my PowerPoint slides, which tried to describe the agile development life cycle. And that was one of the characteristics of it, this idea that you incrementally build your functionality. You start off with your set of user features, and you take the highest priority feature according to the customer, and you design, implement, and test that, and demonstrate it to them, and perhaps deploy it so that it can be used by the end users. Maybe you get some feedback. Then you take the next highest priority feature according to the customer, and you add that onto your code base, and you go through a design, implementation, and testing of that new feature. But critically, not only do you test the new feature that you've just developed, you need to retest the existing functionality that you had developed in previous iterations. And that retesting is referred to as regression testing. So if in developing an application, you go through 10, 15, 20 iterations, that means you're doing an awful lot of retesting of existing functionality during each iteration. And the reason it's important to retest existing functionality is, as you might imagine, when you're developing a new feature, you may possibly break an existing feature. So that's why you have to rerun all your tests, not just the tests associated with the feature that you're currently developing, but all of the tests, all of the features that you have developed previously. And that's really why, so testing is from a time consumption point of view, it's quite time consuming. You have to do a lot of it. And if it were to be manually done, then it just wouldn't pay really, because it consumes too much manpower, person power. So that's why automating testing is so important. That's where you get the real value. Now, all I'm saying down here is that, your mindset as a tester, like this should be your mindset, right? That code that isn't tested, you assume it doesn't work. That's kind of your mindset. Rather, everybody thinks when they write their own code that, well, I wrote it, I'm pretty happy with it, I know it works, kind of thing. But that shouldn't be your mindset. You should always think that it doesn't work and prove to yourself that it does by subjecting it to tests. The second part of this kind of mindset I'm saying is that code that isn't regression tested, i.e. you haven't tested it over and over again. Code that is not regression tested will eventually kind of break. Eventually you will do something to it to cause it to not function. Anyway, so that's enough about that, I guess. Now, this is very much kind of traditional stuff, but in traditional terms, there are 4 different levels of testing. That's another indication of how much effort needs to go into testing. We have this notion of unit testing, which is where you're testing the individual units within your code base. Now, depends on the language that you're using, but a unit could be a class. If it's JavaScript and you're not using classes, then I guess a unit corresponds to a function. So you have to test each unit in isolation. You also have to do what's called integration testing. Integration testing is in testing those parts of your code base that is interacting with some sort of external entity or resource, whether that be a database or some sort of remote service. You need to test those kind of connection points. We refer to that as integration testing. System testing is where you're testing the entire application as one entity. And acceptance testing is essentially the same as system testing, where acceptance testing is notionally driven by the customer. Some customers actually carry out acceptance testing themselves. I guess if they're paying a lot of money for business software, they want to be happy that it does what they require it to do. So these are the terms that we would use in traditional of the traditional terms that we would use. We'll still use unit testing. We still use that term today. Integration testing, maybe system testing, acceptance testing, maybe slightly less so. If you're talking about web applications, which is what I'm talking about down here, and I'm bringing up this point because this is what you will be doing in web app dev. But when you're developing a web application, then we talk about unit testing. That's still relevant. We talk about API testing, where we're testing just the back-end part of your web application. Roseanne will talk about front-end, back-end to you, or may already have done so. So we talk about the testing of the back-end, which we refer to as API testing. And we use the term end-to-end testing. End-to-end testing is essentially system testing, but it's a more kind of modern term. The agile approach to testing. So when we're doing testing today, then really because of the argument that I made at the beginning, the fact that you've got to do so much retesting or regression testing, then you have to really use a testing framework to facilitate automated testing. And that's what the focus of what I want to really look at eventually is to start looking at a testing framework in the context of JavaScript. Each language has its own testing frameworks, many of them. But if you are developing software following an agile approach, I've already made the argument that you need to automate your testing. And that really means that you need to use what we call a testing framework. Alternatively, you could write your automated tests using just custom code, but that really doesn't scale. And I'll make that argument in a while to you. Point number 2, all application code must have associated testing code. Kind of what it really means is that for each piece of application software that you write, you've got to have a corresponding piece of testing software. So you're essentially developing 2 streams of code, your application code and your testing code. And that's not an insignificant point to make, right? You are actually developing quite a lot of code, and the purpose of this code is to test your application code. So it is quite time consuming developing these automated tests. But the win is the fact that you're doing so much regression testing. You're reusing those automated tests over and over again. Point number 3, obviously bugs will eventually occur in your application code. Once a bug occurs, you obviously debug it, but having debugged it, you fix it in the application code, and straight away you should now write a test. You should add some tests to your set of tests to ensure that bug doesn't reappear at some later stage. And finally, follow the test-driven development process. I'll talk about that at the end. Arguably, I could say this point number 4 is optional. It's quite a difficult skill to master, this test-driven development approach, but I'll talk about it at the end. So the first 3 we can probably relate to, not number 4 at this stage, maybe. And the consequence of adhering to those principles, the consequences are these here. Obviously, because you're doing so much testing, presumably there's going to be fewer bugs in your source code. Sorry, just give me 1 second now. Number two, okay, during development, because you are doing so much testing, that it really means that during development, you always have a working application. It may not be complete, but it is working because you've done so much testing continuously. You have a functioning application, and that can be beneficial because you can always demonstrate your application to presumably your customer at any stage. That's one of the benefits of doing testing in the agile way. And number three, then it breaks the cycle. You see, with the problem with the waterfall approach was in waterfall, you remember testing is something that we did at the end. We did our full design, we did our full implementation, and then we did the testing. And really, it's usually towards the end of the whole development cycle is when you're under pressure to deliver your software to your customer. And so what tended to happen was that testing was not skipped entirely, but it certainly wasn't done as thorough as it should have been. Simply because, your customer was screaming for the software, and you had let testing to the end, but that doesn't arise with the agile approach because we do testing almost from the outset. Code is more maintainable because it's always working, I guess. Regression testing, I've kind of made this point a couple of times already. Regression testing is really the reason why we put so much effort into automated testing, because our testing code retains its value over time because we're constantly reusing it. Now, so we actually have to design and implement our tests in code. And so how do we know whether our tests are well designed or whether they're complete or not? Well, the first point I want to make here is that the starting point for any testing is you have a clear specification for the piece of code, that the application code. You have to have that as a starting point. If you don't have a specification for the application code that you want to develop, then you certainly can't test that code when it is developed. It's a statement of the obvious, but that has to be your starting point. And what I'm saying here is that, and this can throw people sometimes, I'm saying that really what you're testing is, you're testing the specification. You're not testing the application code. The specification is always expressing what the application should do, whereas the implementation code is only expressing how it actually works. But the more important part is the what. And so when you're writing tests, you should always be thinking about you should always be kind of looking at the specification that should drive the design of your test cases more so than looking at the actual application code. And that can be something that people find difficult to understand or to follow when they are developing automated tests. Write tests in terms of expectations. So if we are using the specification as the basis for developing our automated tests, and you could almost say that just assume that you don't have the application code in front of you. All you have is the specification in front of you. Then you write your tests in terms of what you expect the application to do, the expectation of the target's behavior. The target in this case is the source code, the application code. What you expect the behavior of the source code to be. By behavior, we tend to mean what output it should generate based on a specific input that you give it. And that's what I'm saying down here. Your expectation for the target's behavior for given circumstances and specific inputs. Circumstances here means circumstances means, for example, if the application code that you're developing is interacting with a database, then the circumstances would be the initial values or the content of that database before you run the piece of application code. Or if you're talking about a function, you're developing a function, and let's say a JavaScript function, and that JavaScript function is processing an array, just like we had with the reducer there earlier on, then the initial value of that array would constitute the circumstances of our tests. The specific input would be, what parameters you pass to the function, and the behavior would be, what result it throws back to you or returns back to you. Okay, this is just a kind of a sentence expressing what a test should look like. I expect something to happen. Some terminology. We often talk about the test target, or the target of our tests. Now, the target depends on whether you're doing unit testing, integration testing, system testing, or whatever level of testing. If you're doing unit testing, then the target is the actual unit of application code, whether that be a function or a class. If you're doing system testing, then the target is the entire application itself. System testing or intern testing are one and the same thing. So the target is the source code, the application source code that you're currently doing automated testing on. Now, in addition to that, we have this notion of user stories, which is a kind of user requirements analysis technique. If you've done user requirements analysis somewhere along the lines, when you do user requirements analysis, you have to document the user requirements some way in English. And it's suggested anyway that a useful way of structuring your user requirements is to express them in terms of user stories. And user stories, it is suggested, should follow this pattern here. This is how you should express the user story. This given, when, then pattern. Given some context, the context again is a bit like our circumstances on the previous screen. Given some context, e.g., given that the database has a certain set of records in it, if it's application level testing that you're doing, if it's unit testing that you're doing, given might be the contents of some object structure or array structure that a function is operating on. The when is where you say what the inputs to the target that you're testing is. So when some action is carried out, i.e., you supply certain inputs to the target. The then is where you express your expectation as to what you expect the target to return back to you. In other words, what should the piece of functionality, what result should it return back to you? So that's how you express user stories. But this can also be useful when you're trying to design good test cases, because I said previously that when you're designing and implementing tests, you use the specification as your basis for coming up with good tests. And now I'm telling you that your specification should be expressed in terms of user stories. So these user stories can be helpful to you when you're actually designing and implementing your automated tests. And I'll show you that in a while. Here's some simple examples of user stories. So it looks like this user story might relate to some sort of banking application that you're developing, right? And you're testing a particular piece of the banking application that allows customers to withdraw money. Okay, so the given which states the particular context for a user story or a test. So given that the bank account is in credit, that's our context. When the user tries to withdraw an amount, I mean, you can read these yourselves. When the user tries to withdraw an amount that is below their or less than their current balance, then this is what you expect to happen. This is what the piece of application code should do. Here's another example in the same context. Given that your bank account is in credit, when the user tries to carry out this particular action, then whatever the result should be. I don't have to fill out the details really, but hopefully you get this. Number one, this idea of expressing user stories using this given, when, then pattern, and so that would mean you'd have quite a lot of user stories depending on the size of the application that you're developing. Now, in the user stories that I showed you on the previous two slides, they're kind of expressed at the system testing or end-to-end testing level, you know. But you can also apply them at the unit testing level. And so let's supposing, and this is just plucked out of the air, let's supposing I've got this function, let's say it's in the context of some sort of academic admin support kind of system, where I've got a function called analyze by region. And this function operates on an array of student records. We don't need to worry too much about the detail of the structure of these student records, student objects, let's say. So this array of student objects is my context for this particular function here. Now, admittedly, now I'm not giving you a specification for this function. I can tell you in my mind, let's say, what the purpose of, or what the objective of this function is, and that's going to be our specification. But let's say the purpose of this function is it's meant to go through all of the records in this array and tell us something about the number of students in each category. Now, the category is determined by a parameter that I pass to this function. I pass it a region parameter. And let's suppose in the region parameter can have two values. It can be county or continent. If I pass it a county as the region parameter, then this function is meant to tell us how many students come from each county in Ireland. And so alternatively, this region parameter might have the value continent. And in that case, this function is meant to tell us something about how many students in this array come from each continent. Okay, it's a made-up example, but hopefully you just get the general idea. So that's my context. This is my function, and I've expressed orally what the kind of a specification for this function in very general terms, admittedly. So following my given, when, then idea that I've been talking about, I'm expressing here now some user stories for this unit, this function. So given that the array has students from Wexford, let's say 3 students from Wexford, 2 from Waterford, 2 from Spain, and 3 from China. When the region is set to county, now clearly with county, the Spanish students and the Chinese students, they're just going to be ignored. So what I want my function to return is I want to return this particular result to me, telling me how many students in each county from my array. And I would only know that this is the exact structure of the response that I should get back based on the specification. Now, I know I haven't given you a full, clear specification, but let's supposing the specification would have stated that the result from this function needs to be an object where the keys of the object are the county names. If county is the region, if county is the region parameter that was passed to it. Another user story might be given the same, given the same context as I've set up here. When the region is set to continent, then the result should be Europe 7, Asia 3. Okay. Yeah, sorry, yeah. And it's actually, it's actually giving me the student records rather than just a number. It's giving me the student records here as well. The point I'm trying to make here is that this given when then pattern, it can be useful as a way of helping you to come up with good design, good test cases, whether you're testing at the system level or at the unit level. That's the point I'm trying to make here, right? That this given when then pattern can be used for designing good test cases, irrespective of whether you're doing unit testing or system testing. Now, so we're just talking really at this stage. Let's get down to some more detail so we can actually do things. Let's talk about automated unit testing. Maybe let's not talk about it because it's now gone. It's now 10 past 3. All right. So the interruption there now, the network interruption. I don't know. It threw me anyway. Whether it threw you or not, I don't know. But obviously, I didn't get as far as I wanted to get. So tomorrow's lab, we can do the functions lab, and we might actually have a go at the. You can see here there's an unit testing lab as well, but I'll think about it maybe in the meantime as to whether it's going to make sense to do this lab or not. We'll definitely do you can work on the JS functions lab tomorrow. All right. It was all a bit patchy now, so apologies about that. I'll leave it at that for now, Richie, and I will meet you in tomorrow's lab. Thanks for that.